Welcome to your soon favorite channel, Mathematics Guru. So today I just wanna start with the basics of trigonometry before you even jump into trigonometry. So what do we need to understand when we say trigonometry, when we focus on the topic of trigonometry? You have to remember that everything we do in trigonometry is based on this Cartesian plane. This Cartesian plane is very important. As it is divided into four, we call it in four quadrants. It's unlike the graphs of functions. These are quadrants, are called quadrants. So it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. I wrote them in Roman numerals because, yes, Roman numerals just to indicate this is quadrant 1, quadrant 4, quadrant. Yes. So in quadrant 1, everything we have there is always positive. Look, when you remember the basic Cartesian plane of x and y, you will notice that on the right hand side x is always positive, right? And then on the left hand side of y, x is always negative. On the top part, y is always positive, and then on the bottom part, y is always negative, right? So if we take a number of y multiplied by a number of x, or we take a number of x, divide it or multiply it with a number of y, we will still get a positive answer. So this quadrant is always positive, right? Then we come to this quadrant here. If you take a number of y here, multiply it with this number, you'll notice that it's positive times a negative. So obviously in the second quadrant it's negative, right? Those are just the basics. And then you come here on this third one, it's a negative times a negative, it will give us a positive, right? And then you come on this one, it's a negative. So you will notice that it's positive, negative, right? But then in trigonometry, we have what we call sine theta, cos theta, and tangent theta, right? These are the three basics that you will find. You will never find anything beyond this unless it's the reciprocals. And the reciprocals goes as follow. The reciprocal of sine, when I say reciprocal, I just mean they just reversed it. It's the opposite of it, right? So if sine, no, it's like this. Sine is always equal to opposite over hypotenuse. What do I mean when I say opposite over hypotenuse? I'm talking about a triangle. And in trigonometry, we always use a right-angled triangle, right? So a right-angled triangle, we know the definitions of a right triangle. It always an hypotenuse. This is the longest side, so it's the hypotenuse. I'm just gonna write that, and then the longest side, right, is always opposite to this 90 degrees, right? And then let's say here, for example, we have theta, right? Then on this angle here, we're gonna have 90 degrees minus theta. Why am I doing that? Why am I writing 90 degrees minus theta? Because in a triangle we have a summation of 180. Everything that is inside the triangle must add up to 180. So when you add these angles, you will get 180 degrees exactly. So as I indicated, the hypotenuse is always opposite to 90 degrees, right? And then the focusing angle that we focus on, theta, here, see here I indicated as theta, right? So we focus Usually they will ask you to stand on this viewpoint, but then most of the time it's always on this side. So then they ask you, which side is opposite to theta? The side that is opposite to theta is this side, right? As you can see, it's across. Opposite means across, another word for it. So this side, we call it opposite, right? It's at opposite. I'm just gonna write up. And then from there, the adjacent side is always adjacent. It means 90 degrees and theta are always in line, so it's adjacent, right? So that's the adjacent. So everything that I write, that sign is equal to opposite over hypotenuse. It's how it is. It will never change. It will always remain like that. So cos, what is cos equals to? Cos is always adjacent and hypotenuse, right? Adjacent and hypotenuse, right? And then here we have tan. Tan is always what? Opposite and adjacent. Opposite and adjacent. Sorry for writing it like that, but then it's always O over A, right? So if you can be able to remember these basic things, then you can always be able to know the reciprocals. The reciprocal of sine is cosec theta. And as I said, if sine is equal to this, then the opposite, which is cosec, it will be equal to the opposite. Like we just interchange. It's O H over O, right? So also the reciprocal of cos is sec. So it will be H over A, right? And then we have the reciprocal of tan. The reciprocal of tan is cot. So the opposite of that is A over O, right? So these are the basic things. Now, these things, we are told that these things can also be found in that Cartesian plane. Like I said, the Cartesian plane in trigonometry plays a big role. We can never separate the Cartesian plane with trigonometric function. These are what ratios, like ratios. As you can see, a ratio is always dividing, right? So what trigonometry then says, in the first quadrant, sine is positive, sine theta is positive, cos theta is positive, tan theta is positive. That's how it is. And it's also true about the reciprocals, right? So I'm not gonna really focus much on the reciprocals, but then you need to know them. They are there. You can't separate them with that. So this is how it is. In the first quadrant, tan is positive, cos is positive, sine is positive. And then we go to the second quadrant. The second quadrant, it tells us that everything except sine is negative. So that means cos is negative, cos theta is negative, tan theta is negative, but sine is always positive. Sine theta is always positive. Now, if I were to prove that, let me take the second quadrant. Let me draw the right angle triangle. This is how you draw the right angle triangle on your second quadrant. It's always looking like this. There's 90 degrees. So, what to prove that hypothesis that they're talking about? We all know that this is a hypotenuse, right? And then since it's opposite to that, like I taught there, and then theta is always here, right? It's always nearer to the point of zero there in a Cartesian plane, right? The opposite of the opposite side to theta is opposite, right? We all know that. Hypotenuse, opposite, and then adjacent. I'm just repeating what I did there. So what it basically means is that the hypotenuse right? Bear this in mind. Hypotenuse is always positive. Always positive. It doesn't matter which quadrant it's in. Maybe it's in this quadrant, the hypotenuse will still remain positive. Also here it will remain positive. Everything, it will remain positive, right? Because the basic the basic explanation to why is it always positive is that we have a circle here. We have a circle, right? And these lines, as you can see, are just radiuses, because the radius is from the center to it doesn't matter how the radius is, right? These are the radiuses, and the radius cannot be negative because a distance cannot be negative. That's why a radius is always positive, because distance is always positive, right? So that's why we have a hypotenuse that is always positive, right? And then the adjacent and the opposite, they always depend on the position of x and y, right? Remember I told you that on the right hand side, x is always positive, and then on the top hand side of y is always positive. Then on the left hand side, x is negative, right? And then on the bottom part, y is negative, right? So it's positive, positive, negative, negative, right? So notice this, the opposite, it takes that sign there. You see, it's gonna be positive here, right? Positive, positive, and positive. And then the adjacent, as you can see, it's already next to a negative. That's why it's negative, right? So what we basically mean is that sine theta is equal to a positive opposite. They usually use numbers, but now I'm just demonstrating on how is it exactly like that. And then the hypotenuse, positive, right? So if you notice a positive and a positive divided by positive is always positive. That's why sine there is positive. Now let me check, let me do the counter one of y of cos, right? Cos theta takes its adjacent, which is negative adjacent, right, over the positive adjacent, hypotenuse, I mean hypotenuse. So a negative divided by a positive, that will give you a negative. That's why cos is negative in that quadrant. And tangent is also negative in that quadrant. If you check, tan theta is equal to opposite. The opposite is a positive divided by a negative, which is a negative, right? Like I explained to you. Okay, now let's move on to the third quadrant. Let me wrap up. So in the third quadrant, we are told that tangent theta is the only one positive there. Tangent theta is the only one positive there. The rest are negative. Sine is negative. Okay. Cos is negative. Okay. So yes, that's how it is. So, and then we come to this last quadrant, which has cos as positive, cos theta as positive. Then sine theta is negative, and then tangent theta is negative, right? So notice one thing. Whatever I just wrote here, notice that sine is positive on two quadrants. So sine theta is positive on two quadrants. This is how you write quadrant, right? So those quadrants is the first quadrant and second quadrant, right? And then we have cos. Cos is positive in what, in which quadrant? Positive in on two quadrants also. I don't have time to write quadrant. So those quadrant is quadrant 1 always and quadrant 4, right? And then we have tan, which is positive on 2 quadrants also. Those 2 quadrants are quadrant 1 always and quadrant 3. Notice something, they are all positive in the first quadrant, and then on the second quadrant only sine is positive, on the fourth quadrant only cos is positive, on the third quadrant only tan is positive, right? So that's how it is. It will never change, guys. It's always like this. These are just the basics of trigonometry. If you want to do trig, you must know these things. And I know these things are a lot to remember. So we have a mnemonic. They call it a mnemonic. So it's so, they write so like that. Ka to. That's the mnemonic that they use in trigonometry. So if you can remember this mnemonic, and then you can be able to remember that sine is equal to opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, opposite over adjacent. So those are just the basics, guys. If you can be able to remember these basics, and then you will never go wrong in trigonometry. So in my next video, I'll be teaching the identities that they introduced in grade 11. So these are just like the things that they will introduce to you in grade 10. So you will have to remember how to find each and everything. But then I think I should also upload a video of angles, playing around with those angles to see which angle falls where. Thank you so much for your time. God bless.